Today's video will define the visitor design pattern. Hello, I'm James Helfrich. It is often necessary for one part of a program to communicate with many different components, even when the different components have nothing to do with each other. And this should be done in a single, unified, and easy to understand interface. The visitor design pattern allows for just such an interface. This video will define the visitor design pattern and demonstrate how to use it in a couple different applications. The visitor design pattern is a communication strategy facilitating retrieving data from a collection of objects without forcing the objects into knowing about the data collection process. This is accomplished by placing the collection of objects in a single inheritance hierarchy and then creating a visitor class that knows about the classes being visited. Now we will start with a captain who will manage a joint fighting force mission consisting of Army tanks, Marine Corps fire team, Navy SEALs, and Air Force helicopters. For this to work, the captain needs to be able to interface with the Army unit, including working with all the custom protocols and procedures. The Marine Corps have different protocols and procedures as well. Of course, the Navy SEALs do things differently than the Army and the Marine Corps. Finally, to manage the Air Force helicopters, a completely different set of regulations is necessary. Notice how our captain needs to be deeply involved in the details of each organization. This means he'll be spending all his time managing the organizations and less time doing what he should be doing, working on the mission plan. To help with this, our captain will appoint an aide whose only job is to collect readiness information. The readiness aide will report directly to the captain and return with information that the captain can use. The aide will know the particulars of the Army readiness report, as well as the Marine Corps, the Navy, and the Air Force. Since the only job of the aide is to translate readiness information to the captain, it is not too much to handle. We'll appoint another aide to help with collecting and disseminating training information, and yet another aide to help with distributing orders. Notice how much easier this makes the captain's job. Regardless of how many different units work for the captain, he only needs to talk with the aides in order to send or receive information. This is a great thing about the visitor. Each individual object can maintain their identity while shielding this individuality from the client, the captain in this case. Let's take a look at the class diagram. We're going to start with the client, and the captain is the client in the previous example. And the client is going to want to talk to element A and element B. Now observe, element A and element B have nothing in common. They have a completely disjoint set of attributes. They have a completely disjoint set of interfaces. And that's important because we don't want to have to change element A and element B just because we want to communicate with them. So I'm going to have a visitor, and the visitor will say, hey, I know all about element A. So I'm going to have visit A, which is going to be able to talk to element A, and it's going to know about set A and get A, okay? I'm also going to have a method called visit B, which knows all about element B, and it knows about its specific interfaces. So that means the only thing that has to know about the interface of element A is visit A, and the only thing that has to know about element B is visitor B. That specific knowledge is encapsulated in just those two methods, and that's the key point of the visitor. Okay, so now I'm going to create an abstract element. And this abstract element is going to say accept, and it's going to take a visitor as a parameter and know this is a pure virtual function. Therefore, abstract element is an abstract class, hence the name abstract. And what I want to do is I want to make element A and element B inherit off abstract element. Okay, now I want to connect element A and element B to abstract element, and I'm going to do this through inheritance, which means that element A is now a concrete element A, and element B is now a concrete element B. Now, because abstract element has a pure virtual function, I must implement accept in concrete element A and as well as in concrete element B. Now, this method, accept, is the only method that is common between element A and element B. Okay, so now the client is going to have a collection of elements. How many abstract elements? And these will all be through composition. And the client will also create a visitor object, and it will pass that visitor object to accept, and then accept will actually be concrete element A or concrete element B. Sometimes there's more than one type of message, the visitor, that I want to send. I can make visit A pure virtual function and visit B a pure virtual function. And notice how it's virtual by the italic, which means I'm going to call this thing abstract visitor because now it's an abstract class. And I have to rename it to abstract visitor, both an abstract element, concrete element A, and concrete element B. Okay, so I'm going to create a concrete visitor, and this is going to visit all the elements with a very specific message. Maybe I'm going to send information, maybe I'm going to retrieve information, whatever it is. And this is going to be a derived class from the abstract visitor, hence the relationship by inheritance. But it turns out there may be more than one type of message I want to send. So a concrete visitor 1, a concrete visitor 2, or as many as I want here. All right, so that's a lot. Let's go through 3 examples so we can see how they're all related to each other. First, let's go back to our joint fighting force. We'll start with the client, who is the captain managing the joint fighting force. This fighting force will consist of many fighting units. There is a Navy fighting unit that uses the INSURV and the TSRA reporting mechanism and the DD1610 order format. There's the Air Force that uses the Fort Element format for readiness information, uses the MTO format for orders, and the CTS format for training. The Army uses the SORTS model for readiness information, and the OPORD format for orders, and the ATG format for training. And finally, the Marine Corps with different protocols and procedures. Notice how these 4 classes have nothing in common. While this scenario may seem contrived, you'll be surprised how often this is the case. Now, we like to put these 4 elements into the same inheritance hierarchy. We will use the fighting unit as the base class. Our fighting unit's base class has no attributes and a single pure virtual method called accept. We will ask each derived class to implement this accept method. Notice that the only thing these 4 elements have in common is this accept method. Aside from that, each gets to keep its individual identity. Next, we'll define a visitor class representing the types of message we want to send to each fighting element. The client, the joint fighting force in this case, does not contain a visitor or as a member variable, but rather utilizes one to send messages to the fighting units. The first type of message we'll send is to get a readiness report. The second message we will send is to send orders to the various fighting units. These 2 concrete visitors are related to the visitor base class through inheritance. Notice how each visitor has a method dedicated to a fighting unit. Right now, there are 4 fighting units, there are 4 methods in the visitor class. If there was 20 elements, we would have 20 methods. Each visitor calls the individual method in the fighting unit's class to send or receive information. To demonstrate how this works, we will show how the captain of the joint fighting force sends orders to all elements. He will begin by creating an orders object, which is a type of visitor. Then the captain will send a copy of these orders to every fighting unit, 4 in this case. One of these fighting units is the Navy. The Navy's accept method is trivial. It is always just a single line of code. It will call visit seals, passing itself, a Navy object, as a parameter. This line of code is simple, but it is critical. Here, it identifies which visit method to call, seals in this case, using a specific version of the order. Now we go to the visit seals method. Notice how we are calling orders visit seals because it is the order that was sent to the Navy. This method's only job is to know how to translate an order from the format the client gave into the format the element needs. All right, let's take another example here. This is going to be chess. So chess is going to have a board, it's going to have a user interface, it's going to have a file system, and it's going to have a network system. And right now, with my current implementation, the chess game has to know all about network and file and board and user interface. In other words, these different components are highly coupled, and this is undesirable. And we need to find a better design here. So now I'm going to have my chess, and then my collection of elements, board, user interface, file, and network. And each one of these are highly distinct and unique. And so now I'm going to have an element, and chess is going to have several elements. In this case, 4, but I can add more later. And of course, board, user interface, file, and network all derive off element. So I want to be able to send messages to the board, user interface, file, or network. And of course, chess is going to instantiate a message object and send it to the element through the send messages function. What kind of messages am I going to have? Well, execute move, and that's going to be one version of a message, but also shut down and start up, and maybe I could think of some other things as well. So network, this specific element, is going to have some very specific functionality like connect and disconnect and send and receive, which are just unique to network, but no one else has. But of course, I have my generic accept. And execute move is going to know about visiting the board, visiting the user interface, visiting the file, and visiting the network. And so visit network is going to know about network.connect, network.disconnect, network.send, and network.receive. So network gets a generic message, and it's going to say, I don't know what to do with this message, because of course network knows nothing about messages. So then it's going to call messages.visitNetwork. Now, visit network knows how to convert this message into the specific calls to connect, disconnect, send, and receive. And so execute move.visit network will say, hey, I need to connect to this address, send a move, and then disconnect. And that's how execute move is going to know how to interface with network. Let's take a look at another example here. Let's say file is going to accept a message. And once again, there's only a one-line code for accept ever. It's just going to call messages.visitFile. And it's done because it has no idea what its interfaces are going to correspond to. But now visit file is going to say, hey, file, open, append the move, and then close. And now a visit file will know exactly how to execute this specific action onto my file interfaces. Let's look at one final example here. An inventory program has a report feature describing the amount of assets, the value of the assets, and a variety of other properties. The assets are each stored on several systems. The shopkeeper system, and I don't know who made that, but it exists somewhere, and the up service. What does up service even do? In this case, I don't know, but it's two services we have. And each one has its own custom interface. So the client is going to have a couple systems, and each system is going to have an accept. And what are my acceptance going to be? I'm going to have my shopkeeper system and my up service. Now notice how shopkeeper has get A and get B, which are unique to shopkeeper, and up service has get B and set B, which once again are unique to up service. So there's no similarity between these two. The only shared interface I have is accept, and accept comes from my base class called system, so I have inheritance there. But now I want to be able to send messages. And so I'm going to create my visitor, and visitor knows all about visit shopkeeper and visit up service. And of course, the client is going to be able to instantiate or create a visitor object that is then going to send it to the very accept messages every time it needs to do something. Now my visitor is going to have value assets and amount assets and maybe a bunch of other different things. These are different kinds of messages I want to create. And all this is related through inheritance. So let's say, for an example, the client wants to know the value of all the assets. Then it's going to create a value assets object. It's going to send it to accept. Accept will then be accept shopkeeper. And shopkeeper says, I have this message. I have no idea what to do with it. So it's going to call visitor.visit shopkeeper, which in this case happens to be amount assets visit shopkeeper. And that will, visit shopkeeper, will then call the specific methods in shopkeeper to get the information it needs in order to send a report back to the client. This is example 44.4 in the visitor section of the message passing chapter of the software design textbook.